Good morning. Today is March 29, 2020. Once again, this is Teacher Ariel, and our subject is Measurements and Experiments. Our topic for today is Series Connection of Resistors. What are the things needed in this experiment? One is analog multimeter to be used as ohmmeter. Number two, breadboard. Number three, assorted resistors. In this experiment, we're going to use 3 resistors, and these are the resistors that we're going to connect in our circuit. What is a series connection of resistor? A series circuit is a circuit in which resistors are arranged in a chain, or in other words, it is connected end-to-end. Take note that the total resistance of the circuit is found by simply adding up the resistance value or values of the individual resistors. Again, what is a series connection of resistors? A series circuit is a circuit in which resistors are arranged in a chain, or in other words, the circuit is connected end-to-end, or resistors are connected end-to-end. Then, the total resistance of the circuit is found by simply adding up the resistance values of the individual resistors. So, take note of the word adding up. The individual resistance of the resistors. Okay? So, our formula to be used is total resistance is equal to RT, which is total resistance, is equal to R1, R2 plus R2 plus R3 plus the number of resistors to be connected in series. Again, the formula for total resistance is RT is equal to R1 plus R2 plus R3 plus the number of resistors to be connected in series, or in so on and so forth, like R1 plus R2 plus R3 plus R4 plus R5 plus R6, etc. What are the learning objectives? In this experiment, students should be able to first calculate the total resistance. Again, the student should be able to calculate the total resistance in series, construct a series circuit of resistors, recognize a series circuit of resistor or resistors, then analyze how a series circuit of resistor works. Again, what are the learning objectives? First, the students should be able to calculate the total resistance in series circuit, to construct a series circuit of resistors, 3. Recognize a series circuit of resistors and analyze how a series circuit of resistor works. Now, let us proceed to the schematic diagram that we are going to use. Since we will use only 3 resistors, the schematic diagram goes something like this. Okay, so this is the symbol for resistor. This is R1. Then R2. Then the last one is R3. So in our activity, we are going to use 3 resistors, which are R1, R2, and R3. Okay, so for R1, we have a color value of yellow, violet, black. So in R1, we have 47 ohms plus minus 5%. Okay, let us measure R1. So first, we will calibrate the multimeter. We will use times 10. Okay. Connect the test prods together and calibrate the pointer to 0 position at the right portion of the scale plate. Now, let us measure the actual resistance. So this is the resistor. So the reading is 4.5 times 10. We have 45 ohms. So let us put it on the table. The measured value is 45 ohms. Next is R2. R2 is, the color value is 510 ohms. Green, brown, brown. So we have color value of 510 ohms plus minus 5%. Then again, let us measure. So we have 48 times 10, we have 480 ohms. Then the last one, we have 100 ohms. The color value, brown, black, brown. So we have 100 ohms. Plus minus 5%. Let us also measure the resistor. we have 10, approximately 10 times 10, we have 100 ohms measured value. Now for calculated value, we will take all the measured value. So R1 is equal to 45 ohms plus 480 ohms plus 100 ohms. Okay, so let us use calculator. 45 plus 480 plus 100 is equal to 625 ohms. So we have the total resistance is 625 ohms. Now, let us construct the resistor into series circuit. We have R1 as 47 ohms, R2 is 510 ohms, okay, as we defined series before in our presentation, that resistors are connected end to end or in chain. So we connected the resistors in chain or end to end. So R1, R2, and R3, which is 47 ohms, 510 ohms, and 100 ohms. Now let us measure the total resistance of this resistor. So we have 50, 55, 60, 65 times 10, we have 650 ohms. Again, we have 650 ohms. 65 times 10. So we have 65 here times 10, which is our range, is 650 ohms. Approximately 65. So our measured value is 650 ohms, which is near the computed value, the measured value of individual resistances. There is a slight difference between the output of the two measurements because of some variations in the meter reading. So maybe we can get the best result if we are going to use a digital multimeter. And also, if you're going to observe, the measured value is not the same with the color value. These are affected by some circumstances. But somehow, the calculated value and the measured value is quite near. So we can simply say that the theory of this series resistor is almost the same as the measured or practical experiment. So let us now proceed to our assignment. For the assignment, students should answer these 3 questions and be submitted to me at the end of their activity. So this assignment, we have 3 problems, wherein we have R1, R2, R3. Compute for the total resistance by using the formula, as well as R2, which is 1K, 6.5K, 50K, compute also the total resistance, and also problem number 3. Again, you can submit this assignment, your preparations, with me in our WhatsApp group. So before you submit this assignment, try to look at this video in our YouTube page or channel. Then take this assignment, submit it to me in our WhatsApp group. Our next week topic will be experiment on resistors in parallel. Again, our next week topic will be experiment on resistors in parallel circuit using an analog multimeter to measure the total resistance, and also computation of total resistance in parallel. Again, what will be our topic next week? Experiment on resistors in parallel circuit using an analog multimeter to measure the total resistance, and computation of total resistance in parallel. Thank you, and always be safe.